Dear students, welcome back. In this lecture, we are going to see the physical and chemical factors affecting chemical degradation or chemical decomposition. The chemical reactions like decomposition reaction or the degradation reactions are affected by number of physical and chemical properties like temperature, solvent, dielectric constant, general acid base catalysis, specific acid base catalysis. So there are number of factors that affect the chemical degradation or the chemical decomposition reactions. So we'll see one by one. The first factor is the temperature. Now, in general, as the temperature increases, the rate of reaction also increases. But the effect of temperature on the rate of reaction is explained by the collision theory, which expects reaction rates are proportional to number of collisions per unit time. So as the number of collisions between the reacting species or reacting molecules increases, the rate of reaction also increases. So that is the hypothesis of the collision theory. Reaction rates are proportional to number of collisions per unit time. But the number of collisions increases with the rise in temperature. Hence, the reaction rate expected to increase with the temperature. So in short, we can say that as the temperature increases, number of collisions increases. As the number of collisions increases, the rate of reaction also increases. As a rule of thumb or as a general rule, the rate of reactions increases about 2 to 3 times with each 10 degrees Celsius rise in temperature. Means if the temperature increases from 10 to 20 degrees Celsius, there is a doubling of the rate of reaction or about 2 to 3 times increase in the rate of reaction. So that is a general rule or the thumb rule which gives the effect of temperature on the rate of reaction. Now as the reaction proceeds, that is reactants are converted into the product. Before converting of reactant into the product, it passes through a state having greater energy than initial reactants. It means it passes through a state, we can say having the maximum energy. Now this acts as a barrier which prevents the conversion of the reactant into the product. In order to convert the reactant into product, the energy is required. That energy is known as the activation energy. If the molecules or the reacting species is having the energy equal to activation energy, then reactant can be converted into the product. So activation energy EA is the measure of this barrier. The effect of temperature on the reaction rate is given by the Arrhenius equation. The relationship between the effect of temperature and the rate of reaction is given by the Arrhenius equation, which is given by K is equal to A e to the power minus EA upon RT, or which can be converted into the, if we convert into the common log K is equal to log A minus EA upon 2.303 upon 1 upon RT. Capital A and EA can be determined by determining the K, that is a reaction rate constant, at several temperatures and plotting the reciprocal of the temperature against log K. So we can, A is the constant actually, that is known as Arrhenius factor or the frequency factor, and EA is the activation energy. So this can be determined by plotting the reciprocal of temperature against the log K, that is a reaction rate constant. Now the slope of the line, this actually this equation is equal to the equation of straight line, that is y is equal to mx plus c. The slope of the line, so 10 is equal to minus EA upon 2.303 R. So from that slope we can calculate the activation energy, and the intercept, that is a log A is the intercept in this case. So from the intercept we can calculate the value of A or the frequency factor. So both the parameter can be determined, that is A, that is the frequency factor or the Arrhenius constant, and the energy of activation EA can be determined by plotting the reciprocal of temperature against log K. So the energy of activation, the equation for energy of activation is derived here, that is log of k2 by k1 is equal to ea upon 2.303 r t2 minus t1 upon t2 into t1. So that is the equation for calculation of the energy of activation. So energy of activation can be easily calculated with the help of this equation. Now the graph is shown here. You can find the log k versus reciprocal of temperature. You can find out at higher temperature the rate of reaction is greater. Actually it is a reciprocal of temperature on the x-axis, that's why the temperature actually decreases, means it is from higher to lower side. So at higher temperature the rate of reaction is greater, and at lower temperature the rate of reaction is lesser.